Hello and welcome to IBuddies Physics. Today we'll be discussing topic 3.1, Thermodynamics. So firstly, let us understand what exactly thermodynamics is. Thermodynamics is the study of the relationships between internal energy, heat, and work. Now, due to the discussion of our previous topic, we already know what work is. So now, let us understand, and we have a basic touch-up on energy, but now, let us go further into the fundamental principle of thermodynamics, energy. So what exactly is energy? Well, it is the power or the capacity to do work. It is something that we need in order to do work. Not just humans, anything, even machines. So energy has a few characteristics, and the most important and common characteristic is this. Energy flows from an area of high concentration to an area of low concentration. Meaning, an area of high concentration has a lot of motion and kinetic energy, which means high temperature. Therefore, high temperature. Likewise, low concentration, low kinetic energy, low temperature. You might have noticed that I've been relating temperature to kinetic energy. So then we can understand that temperature exactly is the measure of the amount of kinetic energy present in an area that causes a rise or a decrease in temperature. Alright? So energy flows from an area of high concentration to an area of low concentration, or in other words, from an area of high temperature to an area of low temperature. But let us go through an illustration to further understand this concept. So let's imagine we have a cup of tea in it. Have you ever wondered why we have these vapors coming out? Have you ever observed that if you take your cup of tea outside to a very cold environment in wintertime, you will see an increased thickness in the water vapor coming out? Have you ever wondered why? Well, let me explain. So, we already understood that energy flows from an area of high temperature to an area of low temperature. Well, in this case, the tea or the liquid in the cup is in high temperature relative to the air, which is in a lower temperature relative to the tea. Therefore, the energy flows from inside to the outside air. And the colder it gets, the quicker the energy flows. Therefore, in colder environments, the thicker the steam or the vapor. But now, the key concept behind this is the concentration. And the concentration changes once it starts flowing from one place to another. And this flow, energy flow, from a high concentration to a lower area concentration is called as heat. Heat is defined as the flow of energy from one place to another. A to B. High concentration, low concentration. High temperature, low temperature. So this flow of energy is called as heat. Be careful not to confuse heat with temperature, because temperature is a measure of the amount of kinetic energy in an area. However, heat is a measure of the flow of energy causing a change in temperature. Now, this flow of energy occurs in a very orderly manner, so as to balance out the energy between the colder and the hotter environment eventually. So when we achieve a state of balance of energy or temperature, when the temperatures equal out between the hot and the cold substance to equal or to have the same temperature, we reach a state of thermal equilibrium. Equilibrium. Equilibrium itself means balance. So, balance of energy equals thermal equilibrium. Easy. Temperature is basically the standard SI temperature scale, and it is measured in Kelvin. Well, Kelvin, not everyone's familiar with it, but we must be aware that Kelvin is a scientific measure of temperature. And 0 degrees Celsius is equal to 273.12 Kelvin. Therefore, to calculate absolute temperature, we have the formula T of K is equal to theta plus 273.12 Kelvin. Now what this means is that the theta is the temperature in degrees Celsius. T of K is the absolute temperature, and 273.12 Kelvin is the addition in order to find the total temperature in Kelvin. This was the basic fundamentals of thermodynamics. In the upcoming video, we shall discuss internal energy and specific heat capacity. So look out for that and keep watching.